All right, welcome everybody to our Geek Talk of our Data Science 1 cohort. This is a really exciting Geek Talk because it's the first graduation of a program that we recently launched, which is our Data Science and Machine Learning program. So this is the first time we're going to get to see the final project presentations and what you guys have worked so hard on during the class. So my name's Alyssa. I'm the campus manager for 4Geeks Academy. I'm going to start the night off with a really brief kind of presentation about 4Geeks, who we are, what we do. I also have Roger here, who is our speaker. He is from a community called Data Science Salon. I think I told you guys in the rehearsal that we were going to have Anna Annison here, who is also from Data Science Salon. She actually had a conflict, so she sent her very close colleague, Roger, who is also from Data Science Salon. So he'll be able to talk to you guys about the industry and kind of like what it's like and talk about data, do Q&A with you guys. So it should be pretty good. So without further ado, I'm going to start off with this nice and brief, hopefully not too boring presentation on 4Geeks. All right. So 4Geeks Academy, we are by nature a coding bootcamp. We have 10 locations in 7 different countries across the world. So just in the USA, we have 3 locations. We have Miami, Orlando, and Boca Raton. We are planning to expand very shortly, possibly to Houston, Texas, or maybe Atlanta, Georgia. We also have plenty of locations in Latin America. We have Venezuela, an office in Caracas with a ton of geeks there. Chile, we have a Latin America online, which gets a lot of Colombia, Mexico. And then we also have Europe locations. So we're in Spain, we're in Portugal, etc. We have to date, between all the locations, 4,500 plus graduates. 85% of our graduates are finding a job within the first 90 days after graduation. We have partnerships already established with major industry players, especially here in Miami. Miami's becoming and already is a huge tech hub. So we work with organizations such as Kaseya, which I know maybe some of you guys went to the Kaseya event. They're a huge tech company here in Miami. eMed is another one. Of course, Data Science Salon, South Florida Tech Hub, Refresh Miami, a ton of organizations here. And then, of course, in our other locations as well. And we've been rated by different platforms as one of the top coding bootcamps in the world. One example of that is we were named the best coding bootcamp of 2022 and now 2023, as the year just ended, by Premios Excelencia Educativa. This is a Spain one. We're among the top 30 worldwide bootcamps by SwitchUp. They're USA-based, and also Course Report has named us as well. They're USA-based. We average 4.9 stars across all platforms, and we are licensed by the U.S. Department of Education. So we are licensed training providers. We are, quote unquote, a real school. Our goal here at 4Geeks is to reduce what we call the unemployment rate. So unemployment means that you have a job. Well, you could also be unemployed, and we still want to help you, of course. We want to reduce the unemployment rate. But the underemployment rate is when people have a job where they're not reaching their full potential. So maybe they have a college degree, but they're working as a waiter, waitress, or as a bartender. Or maybe they never went to college and they've been driving Uber, or they've been working customer service, retail type jobs. Not to say that those jobs are bad, but that you know that you can have a better work-life balance, that you can make more money if you just had the proper training and the proper guidance. So when students take our program, they actually see a salary increase of about 22% after graduation. This number actually went up as we reviewed our 2023 data. I think we're at about like 28% now. So we're even increasing the salaries more. And like I said before, about 85, 86% of those grads are landing a job within the first 90 days after graduation. We have 2 main platforms here at 4Geeks that really make what we do possible, GeekPal and GeekForce. GeekPal means that our students are never alone. So we have a mentorship community. Students can book one-on-one mentorships. They have group mentoring sessions once a week. They have a support channel via Slack in our part of our huge Slack community. So we just support you during the class, but we support you forever. So even after you graduate, you can still schedule mentoring sessions. You can still be in touch via the Slack channel, and we continue that support and that guidance throughout your whole continued career journey. And then GeekForce is our career support track. This is to help you land your first job in tech. So we have a career support team. Valentina Ancieta is the head of career support in the USA. We also have two other Valentinas on the team, which is kind of funny. Sometimes we call them the Valentinas. And then Patricia Perez. And their job is to help you with everything you need, give you all the resources so that you can land that first job. So resume building, interview preparation, both the behavioral interview and the technical interview, resume writing, LinkedIn profile, to give you all the tools that you need to be ready to land that first job. You can see some success stories here on the right-hand side. This is a very, very small portion of what we see all the time. Jean Henrique, he's one of like our best like success stories. He like loves 4Geeks, and he got placed at Microsoft after the program, and he's done many testimonials and has talked a lot about the program. And then we have Urshan, Jonathan, and Alvaro, who were all students that I knew as they were going through the program and landed nice jobs after completing. So it happens all the time. It's definitely possible, but it's a lot on your guys' plate too. So we like to say getting a full-time job is a full-time job. You know, it takes a lot of commitment, getting out there, networking, applying, but our Geek Force program gives you all the tools that you need to make it happen. These are some examples of some companies that have hired our students. You have some bigger companies at the top, like Twilio, Microsoft, Facebook, Uber. And then as you work down towards the bottom, you have more mid to small size companies. But here in Miami, just being a mid to small size company is not a bad thing at all. It's actually preferred by some people. When you work at a very big company, you're very far away from the CEO, you're very far away from those upper level management. Whereas here in the Miami tech scene, there are a lot of small to mid-sized companies where you can have that impact, where you can help grow the company. You learn a lot. You have more job security because those relationships are stronger. So Miami being a startup environment, a lot of our grads do decide to go that way too. These are some partners that we work with. Some of them are educational partners, funding partners, communities. So just people that we want to give a shout out to for making what we do possible. We have Roger here, who is from Data Science Salon. He is in charge of data strategy and community consulting. So he'll be able to give some words to you guys and also do a Q&A in just a few minutes. And then we have two projects presenting tonight. We have Exploring the Impact of Crime Rates on Property Values in Detroit with Israel, Rashid, and Seth. And then we have Estimating Fuel Efficiency of Vehicles with Julio and Ricardo. So thank you very much for your time and attention. At this point, I am going to pass it over to Roger. You can go ahead and share your insight, and then we'll move into a Q&A with you.
Sure. So I found out about this yesterday while I was flying. I'm going to give you my kind of general advice. Actually, the overview was a little helpful. I was able to take a few notes. So I'll just give you a little bit about me. Academically, I have degrees in finance, computer science, and an MBA. And I've been working on data infrastructure, building those teams for a long time, since the 90s. I worked at O'Reilly, the book publisher. I don't know if any of you use any of the O'Reilly books. I was there a long time and helped run the Strata conference that before the pandemic. I see someone just held up their book. And I helped run the Strata conference there. During the pandemic, I was on a COVID task force and helped the state of California figure out how to respond, how to keep people safe. I've been at a couple startups. In addition to working with Data Science Salon, I also do a podcast that's in pre-production. Nothing's out yet. And I definitely, being in the Bay Area, so I'm in the San Francisco Bay Area. Now, I know when you say Bay Area in Florida, sometimes you mean Tampa. I'm pretty in touch with what's going on in Gen I and all that stuff. So I'm going to give you my kind of, it's advice, but it's really like stuff to think about as you factor how you go about moving from what you've just done to what you're going to be doing, because the environment's going to be quite different when you get into your job. And I'm really going to be talking a lot more about human characteristics than technical stuff. I'll just say a couple of things about technology. I have a list of things that I think are important for you to keep in mind for gaining the most learning and working the best with the people around you and the organizations you're in. And the first thing is humility, and couple of that with curiosity. You're going to be wrong. A lot of data analytics is non-deterministic. You're not even going to be able to come to an answer. People are going to come up with things that you didn't know and will like offset what you thought you were coming up with. I think it's important to not come across as a know-it-all, but to absorb that information and always realize that you could be wrong. That diversity really matters. And I don't just mean the traditional things about diversity, but every kind of diversity, cognitive diversity, background diversity, socioeconomic diversity. The more you know about the world and get inputs from people who've had different experiences, the better your data analytics are going to be, because you won't be surprised by things. I'll just tell one quick silly anecdote. When Google has been working on self-driving cars in their Waymo district for a long time, and about 6 or 7 years ago, they thought they were getting pretty close to having the self-driving cars working. They had a couple of million miles in California. It was working really great. They had happened to be working with CMU, Carnegie Mellon University in Pittsburgh. So they shipped some of the cars out there. They started driving. It rained, and it thought the raindrops were bricks. It had been 5 years of drought in California. So these are like some of the smartest engineers in the world, and they didn't have the perspective of rain because they were so focused on solving a particular problem. Working on data, you've got a responsibility to be fair, to be ethical, to consider bias, to do the right thing, because you've got a kind of a unique power, and look for what's missing. Find out what what the environment is like, whatever it is that you're dealing with, and that leads to awareness. This might be like, you're probably all too young for this, but there was a science fiction author named William Gibson who came up with a phrase that's used a lot in tech circles, which is, the future is here, it's just not evenly distributed. And he's been famously kind of ahead of the curve on a lot of kind of like social computer things. And there's a recent profile of him, and they asked him, how were you so far ahead of the time? And he said, I wasn't. I just really pay attention to the present. And that means, so being aware, paying close attention to the details around you, both in your organization and outside of it. Because a lot of analytics is non-deterministic, particularly as we get into Gen AI and things like that, that means some things are not going to work out by definition. So what you should be thinking about is a portfolio of projects, of initiatives, and so forth, because some are going to work and some are not. Like running things as a series of experiments, which we're going to get to in a minute, a little more about that. The last thing on my little list is reciprocity. Humans have as a fundamental emotional drive is reciprocity. The thing that makes us different from other creatures is that we work together, that there's community. I saw is it Geek Pal? Take advantage of that. When you work with people, buddy up with people. No analytic thing should ever go out without it being vetted by someone else, because you just don't know what you missed until someone else takes a look at it. There is a French philosopher that very few people have heard of, but I think should be the patron saint of philosophy for analytics. His name is Gilles Deleuze, and he talked about a lot of things in the mid-century to the 70s, actually even later than the 70s and 80s. But he had three things that I think are related to the things I just said, but are like things to keep in mind in terms of how to go about maximizing your experiences, both personally and professionally. The first is the importance of difference and multiplicity, that trying to have as many experiences as possible will just broaden your worldview and give you more information for making the kind of decisions and picking paths you want to go on. That you're always in the process of becoming. There isn't an end state. You're always learning stuff. The example Deleuze uses is very smart philosophers have spent 6,000 years writing a philosophy of the human condition. If it was solvable, they would have figured it out. It's not solvable. I think a lot of analytics are like that. You might have heard this famous quote from George Box, who was a statistician mid-century, who said, all models are inaccurate, some are useful. So no matter what you're doing, it's a facsimile of what's going on, and it gives you indications, but it's not the end state. You also personally are always becoming. You always have a next thing to learn, a next thing to tackle, and to live a life of experiences. And that relates to the whole portfolio approach, is that the more experiences you have, some will be good, some will be bad, but you're increasing your ability to learn. And Anna had told me this was about 10 minutes. So I'm happy to go longer or shorter or whatever, but just give me a sign, Alyssa, if I'm going too far on this. If you haven't heard of the book Super Forecasters, or if the concept wasn't covered in your coursework, it's worth looking up. An academic named Philip Tetlock ran a bunch of tests and found people who, particularly in the political social environment, were better predictors. And what they found is that there were a couple traits that these super forecasters had. And if you can live these, you will just end up being better off. Probably the first thing is to not be ideological about what you're looking at. In other words, don't come in with preconceived notions. Handling anchoring bias. Anchoring bias is that you're influenced by the first thing you see. The first thing you see does not represent everything. Try to keep that off to the side. You have to be open to new information so that you can take the most recent thing, even if it's against everything you just thought you found, and be able to factor that in and be able to pivot. So being open, being flexible, being good at pattern recognition, seeing the kind of bigger picture, having cognitive flexibility. Of course, you need cognitive ability, right? You need to be able to think. So critical thinking, context awareness. Now, I've just said a bunch of things. You're not going to remember all those, but the broad things are to have that flexibility, paying attention to detail and so forth. When you're describing things, what Tetlock and his team look for is people who use words like but, however, and although, meaning that they're not saying this one thing is true. Here's what we found, but here are the things to think about. Here are the things that run counter to that. Here's what we don't know. So bringing in things as completely as possible. And if we have time at the end, I can talk about kind of a Bayesian approach to this and how this super forecasting fits in with a Bayesian approach. I've been a little conceptual. I'll get down to you're going to be working in businesses. Know the business. A lot of analysts come into a place, they get hired, looks like a good job, but they don't know much about it. Some of the best analysts I know have some kind of like alignment between some personal interests, what makes them smile, and what they're working on. I was just talking a few days ago to a guy who works for anyone who's a musician, works at Reverb, the company that's a marketplace for musical instruments. He was in a band. He was a music major as an undergraduate, kind of fell into analytics and loves both of them. And you can bet that he does a good job of bringing those things together because he's enthusiastic about both things. You're into numbers. You've been learning math. You've been learning how to do analytics, probably notebooks, some visualization. That's all great. It's static. You need to learn how to do storytelling and how to provide a narrative. Humans are geared towards that kind of thing. There's a rule I've always told people on my teams that the most that you can convey to someone else is 4 things plus or minus 3. So depending on the complexity of it. I think as analysts, you tend to like, here's how I did it. Here's 100 things I found. That's not going to work. You need to like figure out what kind of narrative line brings someone from what they didn't know to now what you want to let them know and have as inputs for their decision making. The realistic thing about working in an organization is that power matters, that you're going to be doing things that are going to be frustrating. There's this concept called HIPPO. I don't know if you guys have talked about what a HIPPO is, but it's a high paid person's opinion, that it doesn't matter how much analytics you did. If someone that hasn't been bought into this disagrees with you, they're going to win out, particularly if they're higher up in the organization. That means you need to go out as you're doing your work and make sure you have allies, that you have people you talk to, that you're not just heads down and going in your rabbit hole of analytics, but that you're working more broadly. and working on the social networks of the organizations you're in and outside of your organization. Because you probably have customers, you probably got people in some kind of context that if you talk to them, you'll get like probably a different perspective on what's working that will be helpful for you. In your work, you're going to have many like challenges and things to try to figure out. They're going to be tough. And so your real skill, the real superpower you can bring to things is being a good critical thinker. How do you develop critical thinking? Well, one of the things you can do is what are called Fermi problems. If you don't know who Enrico Fermi was, he was one of the pioneers of nuclear physics who helped with the atomic bomb. If you saw Oppenheimer, he was in there at the University of Chicago. But one of the things he did for fun is he would set out these weird problems to try to solve. The classic one that's attributed to him is how many piano tuners are in New York City? Well, how do you figure that out? Well, how many people are in New York? How many people have pianos? How often does the piano get tuned? Pretty soon you dive down to what kind of estimates you might need to get to that problem. Set yourself outside of work or even things that no one has asked you for and think of them as Fermi problems and think about what approach you would take. You're kind of like sharpening your tool set by doing that kind of critical thinking. The last two things I'll go over now. Let's make sure I just look at my notes quick. Well, I'll go over a couple of quick things first. One is there's a famous paper around 2008 called The Unreasonable Effectiveness of Data. Traditionally, data size trumps algorithms. The more data, the better your results. So there's something to think about. I think that there's a focus on algorithms because they're kind of interesting to work out. Quite often, the differences can be kind of slight, or in the real world, don't make that much of a difference. So think about, are you getting enough data to make the decisions you're making? The other thing that's going on in general in enterprise companies is something called data mesh. And if you're not familiar with that, you should get familiar with it. There's a woman named Zhamak Denhagi, and she actually written an O'Reilly book covering the topic, but you can see plenty of information online about what data mesh is. What it basically means is data teams are increasingly there to enable other people in an organization to do their own analytics. And that means you'll be in more of a consulting role to them or an enabling role sometimes to other people. They're not going to be as good at the math as what you've probably just gone through. You need to help them. But that data mesh is something that is definitely happening and it's something you're going to be dealing with. And so it's good to know what it means. Think about the pitfalls of that. One practical thing, and I've talked to some of my podcasts, I interview a lot of people who have all sorts of levels of experience. One thing is really consistent with analytics is when you're given a data set and you're starting to do your exploratory data analytics, everyone starts with regression. Doesn't matter what cool tools you've used, what sophisticated things you're going to do. Regression is the best way to get, there's a great German word, Fingerspitzengefühl, which means literally fingertip feel, that you need to get a feel for what it is you have. Is data quality good or bad? Are there holes? Are there outliers? Regression is a great way to get that. The last thing I'm going to say is you have rare knowledge in a way. You've learned how to use data, analyze it, make some sense of it. A lot of people don't understand what's going on. They're going to be confused by that and so forth. If there's one thing you can be is be kind. Be kind to everyone around you. If you try to do that, you're not going to be condescending towards anyone. You're not going to like try to talk over them. You're not going to take a, well, I know this stuff. You need to listen to me. If you're being kind, coupled with humility, which I think was the first thing I brought up, you're going to be able to deal with people in a way that you're relating to them. You're not telling them, you're showing them. You're not talking down to them, you're talking to them. And I think that's going to be really important in the long run for you if you want to be effective in what you're doing. So on that note, was Alyssa, was that the kind of time frame you were expecting?
That was great. That was full of relevant and valuable information, I think. Thank you very much. I'd love to see if anybody has any questions for you. You can ask out loud, ask in the chat.
Yeah, just
Go ahead,
ask
Stephanie.
out loud is probably going to be the best. I haven't seen anything come up on chat yet, but I'll make sure the chat is open.
Stefan, why don't you go?
Hi, I'll start first. Thank you very much for that wonderful overview of data science. And I really appreciate how you didn't really talk much about, hey, data scientists need to know pandas or they need to know how to upload apps to the web. You really focused on the people skills that are involved. And I also appreciate your emphasis on how you can always be wrong with the rain example or with something like Anscombe's quartet, where you just don't know what you don't know. Your data is always going to be incomplete. I was wondering if you could just speak a little bit to, because most people, there are so few actual data scientist or data analyst roles in this world, and most people will end up in marketing roles and HR roles and finance roles. Can you speak a little bit to the ubiquity of opportunities to use these data science skills, whether or not you are in a quote data science role out there in the real world?
Sure. It has become so much a part of most organizations that no matter where you are, if you have data skills, you're bringing another like special attribute to the organization that is valuable. Now, back in the 90s, if you were good at Excel, it didn't matter where you were in the organization, you were really valuable because you were doing something that not everyone else was going to get. If you've got these data science skills, particularly if you're good at communicating, you're going to become valuable to that organization. So one, on a personal level, you increase your worth to the organization. I think because of data mesh, there's going to be more and more of that. And you mentioned AI, HR. It's really kind of new that HR is doing analytics. That wasn't something that was true, I think, even 10 years ago. Increasingly, you're going to see other parts of the organization being able to do that. The more rigor you bring to that, the better you're going to be. It's easy to be like just pick up some analytics and just try to do stuff because it's something you're trained to do. But if you can make things repeatable, like orchestrated and regular, I think that can really work well. The other way to and I know this isn't quite answering your question, but to become valuable, sometimes what data teams do is build a lot of dashboards, and that's fine. But I think the kind of hidden thing that any organization needs is a newsletter. Someone who goes through, looks at the regular things that are going on, and reports the story that is saying what happened in the last month, whatever the time frame that seems appropriate, depending on the business you're in. And that's an opportunity where people might not know that that's what they should have. But if you start providing it, it becomes super invaluable because people start relying on it. Their dashboards are kind of static. The narrative provides something you can really sink your teeth on. Now, you follow the news. There's been a lot of layoffs in tech. There's just today, Microsoft let, I think, a couple thousand people off. It doesn't mean there's, in a way, fewer opportunities. What's happened over the last 15 years is that the VC community has had so much money and is so in a way, overinvested, and companies got a little lazy around hiring and so forth, that there's a lot of places we're just not running at the kind of lean state they really needed to. And when Silicon Valley Bank imploded and interest rates started going up, the tech world started saying, oh shit, we need to start thinking about cash flow. We need to start thinking about running leaner and making a road towards profitability. We can't just keep growing and expecting to get more money. That doesn't mean there's less to do. Every data team I know needs more people to do more work. But at some point, there's kind of budget constraints and ROI considerations and so forth. So I think there's a lot of opportunities. I still think there's a lot of data team stuff. And I don't know if you guys focus more on data engineering or the data science part, but both sides of the equation tend to require, there's more and more data to gather. There's more and more insights to capture, that there'll be just more to do. And I think it doesn't matter where you are. If you are in an organization like HR, marketing, sales, and there is a centralized data team, make them your good friend so that you can have that crosstalk that I think matters so much.
Great. Any other questions? Go ahead, Julio.
Hey Roger, thank you again for coming. I appreciate all the knowledge you're dropping on us right now. My question was basically what was kind of like your first real world role in this field, and what was kind of like the main thing that you kind of had to overcome to um, kind of get with the program of where you were working, or because you come and you study, and you have these courses and you study, but then you get implemented in the real world, and there's certain things that you have to overcome that you've learned before or that you have to change or something, and you kind of want to hear what those things were, or what kind of role that you had first that helped you, or because yeah, thanks.
Sure. I don't know if many of you have seen the movie Ghostbusters, but in the original Ghostbusters, they get fired from their prestigious Columbia University position. And Bill Murray's kind of saying, uh, I'm not worried. And Dan Aykroyd comes and says, you don't understand. In the private sector, they expect results. And I think that was, in a nutshell, the kind of key thing from academics to getting the real world is that you can do things that look elegant, that are really interesting to you and so forth, but you really need to tie them to something in the business, to something that is going to make a difference to the people who you're working with. So I started off, my first data warehouse project was at a phone company, and we were just looking at what are called call detail records and just trying to make some sense of that. No one had really done that before. And we had all sorts of weird considerations, including how big the data was, because at the time it was huge data. And my sense was by kind of going simple and taking like pragmatic steps, I learned that that's the best way to move something. So we just did something to get it done. My second kind of data science job was I built a data team at a database company called Sybase. And I'll just tell a quick story about it. I was hired, and I kind of casually said, I think I could build a data warehouse pretty quickly. I'm technical. I can code. I can also, I've got an MBA. I can think about the kind of bigger picture stuff. And they said, no, we want you to do a traditional requirements waterfall kind of project to do it. A few weeks later, the company had a bad quarter. My boss kind of stopped me in the copy room and said, remember you said you could do something quickly? And it had to be 90 days now. That would be a lifetime. And I said, yeah. He goes, well, do it. So we went in, we just dove in, we did it. We had something practical, and we were able to integrate things across systems, and that really worked. Like, people were kind of like, oh, wow, they were able to see patterns that they didn't know about before and work that out. My team was super diverse. The Bay Area is quite a diverse place. And so we had lots of different experiences that helped us move. And so I really learned how important that was to moving forward. And their workload was quite high. And I instituted this queuing mechanism so that no one got too overwhelmed. So the way that we did projects was that everyone had, I think the queue was 3 deep. You could have 3 deep of projects. If someone said, I really need this done, they had to convince the other 3 people in that queue to give up their slot, so that they didn't have to be super heroic effort weekend work, but they could do it. The other thing I did is I gave everyone Friday to work on what they wanted to work on. That was analytic. I gave them a little free time we called it supply side analytics, that they could analyze something that no one had asked for. And that way they're learning about the data. And I felt like that was important too, to carve a little time out for that. I would say that the most overarching thing is to remember a lot of data teams are kind of a cost center, even though they're providing a valuable service. And it's hard to like tie direct ROI. So keeping that in mind might help you, like, should I keep going down this rabbit hole, as interesting as it is? Or is it time to like pull up and say, I've gotten to this point. Let me talk to my peers, my clients, to figure out, do I need to go further? Have I reached the right point to do something? The other thing I'll say is, I'm guessing you guys have all learned Python and stuff, is make sure that you can kind of like jump in and do something on your own and get something done quickly, because there will be times when that'll be a big boost for you. If you were to come back and say, oh, geez, now I got to get my developers to do this, I got to get I got to line these people up, it's going to take a month or whatever. there are times when that's appropriate, but there are other times when you just whip something out, it takes some of the pressure off, and then you can make it more production ready and do the right thing afterwards. So making sure you got kind of like a good toolkit of both technical and analytic insight capability.
Thank you for answering my question. I appreciate you.
Any other questions? All right. Well, Roger, I really thank you for your time. Thank you for making this happen. I know that it was like a little last minute, but your insight was, I'm sure, very valuable to all of our students. You had a lot of really great things to say. So I appreciate you for coming.
Thanks. Good luck to you all. And you saw my LinkedIn. Feel free to reach out by that. I think I've got my email there too. So.
Is it here in the chat or where is it?
Oh, on my LinkedIn, I publish my personal email on LinkedIn. So if you go through to that,
I think I have your LinkedIn here. I can drop it in the chat.
Thank you.
I have a quick question.
Sure.
Only for continue this topic. What's your opinion about the large language models?
Well, one, pay attention to what's going on with Mistral, because it's based in France, and they've got a new methodology with their 8x7b model that's called mixed. It's something MIE. It's like mixed something expert method, and it really works well with small models. And so, like the major European languages are going to be covered, right? German, French, Spanish. There's too many people involved. But for other European languages, I think if there's not a lot of like in the big foundation models, people will be able to build something that works using something like Mistral. I mean, Llama 2 is part of that too, but Llama 2 is coming out of Facebook. And I think Mistral being in France is going to be a little more sensitive to different languages and kind of different cultural norms that are in, in Europe. So I think France is trying to make a play to become a pretty major part of the Gen AI question. And there's a lot to be said for that. Yann LeCun, who's one of the pioneers of it, is French. A lot of the guys on Google's DeepMind were French. And then the Mistral folks who came out of DeepMind are French and doing their work in Paris. So worth paying attention to what's going on there. And I think you mentioned all the South America contacts that 4Geeks has. I think there's going to be a lot to be said about what's going on in South America as well. I think there's a lot of opportunity there, and I've done work in Peru and in Uruguay, and there's a lot of really sophisticated folks down there, and I think Gen AI is going to level them up some. Increase coding productivity and language coverage.
Thanks.
Any last questions? Go ahead, Julio.
Just one more question. What do you have any suggestions like after we're done with the course to kind of any sources or anything you suggest doing to keep our kind of minds and tools sharp with the things that we've learned? Because I know after the course is done, it's kind of up to us to learn more. I mean, I feel like I'm no expert, but I'm definitely a beginner expert for sure. But afterwards, you suggest any I don't know, sources or anything that helps?
Sure. Yeah, I actually have a bunch. The first is if there's something you like, there's probably data associated with it. So if you like baseball, you can pull down baseball stats. If you like music, you can pull down, the top 100 stats and look at that. So if there's something that you like, your own self doing like quantified self stuff, how many steps you're doing or if your exercise regime or whatever, that's like a great way to do it because you're motivated from both angles. You want to keep your analytic skills up, and it's something you're interested in. It's almost like your own personal Fermi problem. 2, Kaggle has a great bunch of little data sets, and you've got other people who've worked on them. So not only can you do your work, but you can see how other people approach the problem. The other thing, the U.S. government has some really interesting data. Some of it you can pull from a site called USA Facts. That's actually a private company, but you can pull data from them. But the Commerce Department and the Census Department have great, big, hairy data sets. The first thing I did when I was on that COVID task force was pull down the census data for California. I started doing all sorts of slices of what was going on there. And the data is free. You can even go into things like BigQuery has a lot of commerce data and census data just there. So you can just pull it for free from a BigQuery table that they provide in their kind of free pane. If you've ever gone into BigQuery, you can see at the end. Using stuff like DuckDB. Does everyone know what DuckDB is? DuckDB is a fantastic little tool for having your own personal database. It's fast. It keeps data compressed. Unlike Pandas, it doesn't have scale issues the way Pandas runs out of like oomph when you run out of memory. It's SQL, and it's real SQL, but it's geared towards analytics. If you guys have done much SQL, instead of having to say group by and then listing all the columns, you can say group by all. That feature alone makes it, like a real bonus to have. So you can pull these data sets. You can use something like DuckDB to work it. If you haven't heard of Marimo, Marimo, it is a new notebook that just kind of came out, and it's reactive. So you can have sliders and stuff like that. So you can build like little visualizations that people can control parameters on very easily. It's kind of cool to do. And I think for storytelling, it can be a nice thing. If you've been using Pandas, you should know what Polars is, Polars. It's a faster, more scalable data frame thing. So, well, it sounds like I don't mean to just list a bunch of leading edge stuff. My point is by looking at these things that are kind of recent and doing your own data, you're not only working with the data, you're working with these kind of new tools and kind of expanding your ability to kind of work through these things. So you'll have to learn something new, which is always good, but it's not so far off of what you already know, right? DuckDB is just SQL. Polars is just data frames, which I bet you're pretty good at, and DuckDB is SQL, which you've probably been introduced to. So I think doing that, a lot of people I know will tackle some kind of thing that interests them and spend a little bit of time to help keep themselves sharp on it. So it's a great, you're on the right track thinking about that as something to do.
Thank you. I know I have like one last question, but this is my really last question.
It's okay.
Just because we just talked slightly in our courses about the ethics of being the data science and gathering this data and presenting it correctly. Where you have like examples of where you yourself had to kind of like rework models that you did or rework projects you did because they weren't necessarily ethically correct, or they weren't like the data wasn't collected in like a right way, even though your model was amazing and you got the answers you wanted and the predictions you wanted, the way you gathered the data wasn't really the right way. But yeah, just more experience on that, because I mean I don't really know what is, well, I mean, we all know what's right and wrong, but what is right and wrong when it comes to data? Like, is it just gathering things that people have privately, or is it just making a prediction on something that is biased? Or I don't know. I'm trying to get a more understanding on the ethical part of this before we kind of dive into other things.
You've brought up like a lot of the main points of what you should be looking for. Is any sample you have representative? So I'll start with the kind of bias side of things. Is it representative? It's one of the great things about census data. It's a way to figure out whether people have, what's representative of either a region or state or country, what's there. Looking at outliers in that space and making them, like, let me say this a different way. when you see outliers, instead of saying, oh, I should just get rid of those, embrace the surprise, because what you're likely going to find is that it's something that could have some kind of ethical or responsibility perspective to it. So it's, and just because the country has had issues around race, that if you look at any kind of financial data, it's going to have the bias built in of a system that, like, kind of officially was biased against folks for a long time. And keeping that in mind and not taking the data as just what's there, but that what might be behind it. And then as your own personal thing is just the golden rule. If you're looking at data that has personal information, would you care if your data was part of that? Health data is the easiest one to think about. I happen to do a health, like a privacy health data project a few years ago. And you think about, well, what could be wrong with that? And then, you have a test that it has an embarrassing or including affecting your job, your ability to get a job kind of result. It should be, it's no one's business. And so you've got to be careful with that. So you've probably heard the term PII, personally identifiable information. So the things that you think you could get to someone, or reasonably someone could use analytics to get to who someone is, that should be the flag that I need to think twice about this. I need to think about what's there and whether I should be doing something with this or not, and then make the right decision. I'll just say one other thing about Gen AI that I think is particularly, because it's so much in the news, because Gen AI is really based on history, it's got a lot of nasty stuff in it. And they try their best to get out of it. I happen to use Claude because I appreciate that Claude at least tries to limit that stuff. But it's going to be there. And so anything that I think you pull where you're bringing Gen AI in, you've got to have a sense of, is the history there something that's reliable? And am I being responsible in relying on that history? Is there something that I probably want to think twice about? This isn't an ethics question, but it's just a thing to think about. When I started the COVID task force work, we had a big team, not that big a team, but a pretty big team of people from all sorts of different things. And everyone's saying, okay, what kind of historical data do we have? We have none. There'd never been a pandemic before. So everything had to come from, we had to like first principles on what worked and what didn't. And at one point, someone suggested, why don't we put cameras up in places where people walk around in Los Angeles and in Oakland and San Francisco, the big cities? And it's like right away, luckily someone said, if you can identify the people, that's really impinging on their privacy. And we didn't do it. Now, the one thing we did do, and now you'll see this all over, is we started monitoring wastewater for virus load. And this way we could see where things were moving around. No one knows who it came from, but we know that the area was in. So we're able to get the kind of data we wanted to have to try to help keep people safe and to allocate scarce resources without violating anyone's privacy in a way that would make someone uncomfortable.
Thank you very much. What I get from it is pretty much like a thin line between your own morals and then the greater good, and it's a real thin line between that.
It's not easy, and you really have to think about it. It's that's why it's good to have diversity. I happened to be at an event with Anna this week, and someone at the conference was talking about people on a panel, and I didn't even think about it, but they used some language that some women in the thing really were bothered by, and they came up and talked to me about it afterwards. I'm sure the person didn't mean anything wrong, but he was insensitive to how other people would feel. So, I just talked to him quickly about it. But, you're not always going to be that kind of situation, but having someone who would be sensitive to this, who's led a different kind of life than you has, can really help as you navigate that thin line about where where it should go and where it makes sense.
Thank you so much. Appreciate you, Roger.
Any other questions?
I see all the claps. Thank you for that. I appreciate it. So, yeah. So should I hang on, or is
So we're going to move into the final project presentations now. We have 2 projects presenting tonight. They're each going to take probably about 15 minutes, so you're more than welcome to stay and watch. I'm sure our grads would really appreciate it if you have the time. And we can start right now.
Sure, I will mute. And good luck to you all. And I'll reiterate, be kind.
All right, so our first project is exploring the impact of crime rates on property values in Detroit with Israel, Rashid, and Seth. Take it away.
Hey everyone, how's it going? I'll be presenting and Rashid will start first. Let me get this up and running. Hold on, sorry.
Okay. Hey, everyone. Great to see you here virtually. We are Seth, Israel, and I'm Rashid. Pretty much a bunch of data science geeks. We're diving into Chicago's property and crime scene. It's not just about the city's awesome vibe and cool buildings. We're also tackling its tough crime issues. What's our mission? We're really looking to unravel the secrets of Chicago's real estate and how crime fits into the picture. So we've got some neat insights to share. So let's get this show on the road. Thanks for joining us. Okay, next slide. Okay, if you go to the next slide after that, thank you. So let's take a moment to talk about kind of like the backbone of our project, the data. For the property insights, we tapped into the Home Harvest. It's this really cool real estate scraping library. It pulls information directly from realtor.com, and it like formats it in a style of MLS listings. We're talking about it's a pretty hefty data set here. It's like over 313,000 properties sold over the last 10 years, detailed across 27 different columns. This includes everything from basic latitude, longitude, which is really helpful for us, to more specific details like property data. We're looking at square footage and even how many days the property was on the market. And then switching gears to the crime data, we went through the Chicago data portal. This is where the Chicago Police Department keeps an updated record of reported crimes in the city. Massive database, about 250,000 records seems per year, and it totaled to about 2.3 million in the past 10 years, covering 32 different columns. Okay, next slide. Thank you. All right, so we're gonna jump into the crime data. This graph is a bit of a roller coaster. Shows Chicago crime data over the nearly a decade, starting in 2014. You see crime hovering just above 250,000, and then there's this wave-like pattern, and then pretty stable until 2019, when you'll notice things take a surprising dive and drops below 210,000. There's a twist post 2020. There's a crime rates hit like a rebound button almost, and not just returning to previous levels, but even surpassing them. So it's what's behind the seesaw effect? The dip around 2019, 2020, could be due to a bunch of reasons. It could be policy shifts, it could be policing strategies, could be societal changes, maybe a multitude of things. And then post 2020 spike, that's kind of a head scratcher. Did earlier solutions lose steam, or did new factors come into play? Be interesting to dive more deep in that. So this is pretty colorful graph showing Chicago's crime rates month month for the past 10 years. Each line is a different year, as you'll see, and then 2020 is in dark red, and then 2020 is in light pink, and so on. And you'll notice how the crime peaks in the warm months. Things like July barbecue, August beach days, and then each year is a bit different. And then 2020, you'll notice it goes down, probably because of the pandemic. And then in 2023, you saw a bit of a crime rate dip compared to the pre-pandemic times. Go to the next slide. So this is a heat map, kind of like a mood ring for Chicago's neighborhoods. It shows how crime rates have changed year over year. Blue means the crime went down. Red means the crime went up. And then you look at the central neighborhood, huge crime drop in 2020, but then it bounces back up. And then the north side, even crazier with massive spike in 2021. Each area kind of tells a different story. Like the far north side and the far southwest side are pretty chill compared to the wild swings in the central and north side. And then in 2020 was a quiet year almost everywhere thanks to the pandemic. But then post 2020, it's like the crime rates are playing catch up. Pretty interesting patterns. And then moving on, so this is a chloropath map. This one is of property crimes in Chicago for 2023. It takes the monthly average for each, and then in per capita, taking the total population, and you'll notice like the densities of the crime in kind of like the southwest side, south side, west side area, and then later on in the subsequent slides, we'll look at like the pricing of these areas, and we notice in the different crime categories that similar kind of pattern in these types of south side, southwest, west side kind of areas. And then go to the next slide, please. And then this is we'll jump into the property data. We're going to start off with the pricing for. We'll start from the north and kind of go our way down to the south and look at kind of the pricing and see how the pricings differ. Here, the far north side, it has like a range from 240 to 380,000, and you can kind of see you can increase trajectory there. You go to the next slide, and then north side, the range is even higher, 550 to 800. Pretty big difference. Likely due to like some outlier housing prices. Still like the median is like around 600,000. And then you go on to the northwest side, it kind of dips down to around 250 to 450, 100,000 range. Might be due to the crime. I'm not sure, but the median and the mean are more closely together here. And then we'll go on to the central side part of the neighborhood. This is where downtown is. The price is from 1 to 6 million. Pretty high up there. Downtown area, so kind of expected. And then, but downtown does still have that crime. But here, we're looking at the west side, which is kind of there's a good amount of crime there, as you noticed. And then there's a lot bigger range, 150 to 450,000. And then going to the next slide, we go down to the southwest. Range here is 150 to 325, going lower. And then lastly, the south side, the range is 200 to 250,000. So, and then this graph kind of shows the days on market for each neighborhood, and you'll notice how like the neighborhoods go in a pattern together. They all kind of take the same movement, and there's a big dip in 2018. Interesting, and then it goes up, and then it goes down to 2020 and 2021. you know, and then now it's at like a much it's at a higher average days on market compared to the past 10 years. Yeah, and then I'm going to pass along this to Seth for the modeling part.
Hey, how's it going, everybody? So after trying many models to fit our data, we decided to go with a ridge regression model for the crime count. So basically, our model focuses on predicting crime counts based on various housing-related features. And while more conventional models will often predict housing prices, our approach more seeks to understand how housing information may be an indicator for crime counts in the city of Chicago. So our first two features are latitude and longitude. So latitude, so the model learns from the data, and the inclusion of the geographical coordinates allows it to consider spatial information when predicting crime counts. Longitude and latitude can provide information about spatial patterns, crime hotspots, neighborhood characteristics, correlation with other variable, spatial dependencies. For example, crimes may show spatial dependencies where occurrences in one location influence nearby areas, and longitude and latitude help the model consider these dependencies for more accurate predictions. Our next two features are sold price and year built. So by incorporating sold price and year built as features, the model has the opportunity to learn complex relationships between economic conditions, property types, neighborhood development, and crime counts. By using these two features, it can provide details and information on the economic intake, the property type, the gentrification, the age of the infrastructure, and the maintenance and upkeep. For example, older properties might need more maintenance, impacting neighborhood appearance. The model explores if property age correlates with crime rates, factoring in the maintenance and urban planning changes. And our final feature is neighborhood. So by incorporating neighborhood as a feature, the model can capture these nuanced contextual factors, allowing it to better predict and understand variations in crime counts across different areas of the city. It can provide information and details on community resources, policing and security measures, the social environment, housing conditions, historical patterns, demographic composition, and social economic conditions. For example, neighborhoods vary in socioeconomic conditions, impacting the crime rates. Lower socioeconomic status may lead to higher crime due to increased poverty and unemployment. These are the metrics for the regression model. To put it in simple terms, the model performs exceptionally well, accurately predicting crime counts based on the given features. This is a feature importance bar plot showing visually the feature importance of each of our features to the crime count target variable.
All right, thank you, Seth. Now I'll demonstrate the web app we built. Oops, sorry. Give me 1 second here. All right, so we used Streamlit to host our model. And we have this landing page here. We talk about predictive model for housing analysis. You access publicly accessible data. You have examples of the data right here that you can check out. We're trying to forecast the number of crimes in neighborhoods by considering the different factors related to housing. As Seth mentioned, and Rashid mentioned, unlike typical models that are just trying to find like changes in housing price, maybe to give someone a better deal or to provide the consumer a service, we really wanted to focus on how information about homes could provide insights into conditions in the city of Chicago and potentially lead to action on those factors that could reduce crime. So we have some of our best graphs from our project here. Over here we have I'm going to save you the loading times by having it open another tab. We have an interactive map here that shows the city of Chicago overlaid with the different neighborhoods. This is data from 2023 only. So it can kind of show you the different neighborhoods of Chicago and the breakdown of different crimes here. And this is an example of the crime database that we used. Lastly, we have this predictive model. we use a ridge model, and we wanted to make it easily accessible for people to mess around with, to learn and kind of explore how the year the property was built. So let's say 1970, 1980. Maybe a property sold for $350,000 in the Ashburn neighborhood. So the predicted number of yearly crimes in the area of a $350,000 property that was built in 1980 would be 4,829. And so you can see as you change the year it was built, and you change the sold price, you even change the neighborhood, you'll get different values. Yeah, and so let me go back to this real quick. So, we wanted to offer a unique perspective on the potential connections, not just look at monetary value. As a foundation, we're going to use, we can use for a more comprehensive exploration. There's a lot of interplay there between housing values, housing conditions, and crime. So we wanted to do that. If we had more time and resources than we were available to us, we would have expanded our database to include more historical data, more features, really have dove a little deeper into the data, maybe whipped up a couple more models that we could have had on the app, expanded our functionality, maybe been able to make the map different based on the year you put in. We had a lot of ideas of stuff we wanted to do. We just weren't able to quite fit it all in time. So yeah, and then we just wanted to say thank you to 4Geeks, our professors, Stephen. Sebastian's been invaluable during this whole process. Pedro, who was our previous professor before Stephen stepped in, so graciously. And then all our families for supporting us during this process. Thank you very much. And if the other guys, you want to say anything, go ahead.
Very nice job, guys. Great project. Anybody have questions or comments for this group?
I would like to comment that the group did a really good job of ensuring there was no data leakage. Where your answer is kind of accidentally found in the training data set. So they did a really good job of ensuring the proper data governance when they built their models. So I'm really happy with the models that they eventually came out with.
Only to say something for you guys. I'm really happy to see this project ready and working, because you take the time and do a lot of effort to create the solution, and I know that this is something like you can do better in the future, because you have the skills and the necessary to do this type of work better in a work or something like that. Thank you guys for your time. I really enjoyed the journey with you, with us, all of us. Congratulations.
Thank you.
I would like to say I like the way your presentation is set up. It's very visually and interactive, and I like the way you guys just set everything up. It looks really nice, really nice.
Thank you.
Yeah, I agree with Julio, kind of going back to what Roger said about the narrative and how you present the story. You guys did a really nice job with that.
I was gonna say, I really like how you guys pointed out the spike in housing right after COVID up to post 2014 levels. So it's very interesting to see that skyrocket up in pricing as well as crime. So you think the crime would go up, you think the price would go down. It's the opposite. They all went up at the same time. So it's very interesting to see that.
Any other questions, comments? All right, very nice job, guys. We'll move into the second project and our final project, which is estimating fuel efficiency of vehicles with Julio and Ricardo.
Hey guys, my name is Julio. I'm presenting with Ricardo, and Ricardo's going to be presenting now. Pretty much our title, our little logo that we have. Kind of wanted a mix a logo of like AI with the fuel data that we have, trying to make a better, more fuel efficient vehicle for pricing for consumers, and then also save the planet at the same time. So I think the logo really represented that.
We're seeing this on like a horizontal view. Can you share it
Oh,
full screen?
Oh, okay.
Yeah, I'm not sure why. Give me one sec, because it's not on the horizontal monitor.
Maybe your resolution, if you change that or something like that.
Maybe at the full screen, if possibly. I'm not sure.
Is that better?
Much better. Thanks.
Yes, it is.
Let me move you guys, and we're ready. Okay. Continue, Julio. You're muted.
My bad. An introduction to ourselves and our teams. My name is Julio. My second course here at 4Geeks. This course is very informative, and I really like jumping into the data. I didn't know how much I was going to like gathering all this data until I went into this course, and I liked to figure out these problems and find solutions and see different ways to fix them and stuff. I just want to talk about one of the personal challenges in the course was basically the hardest part about this course for me was just getting the time series set up. It was one of the harder things for me, just because it's a lengthy process to process all that data for a time series. But yeah, that's just for me. I'll hand it over to Ricardo, who's going to introduce himself.
Hi, my name is Ricardo Hernandez. I am from Puerto Rico. Just to talk about a little bit about this course, I really enjoyed this project. Throughout the course, we were doing like little bits and pieces of projects and models and stuff like that, and actually seeing the project itself from the ground up, from the data collection, the EDA, to the model building and the deploying. It was a really exciting process, and I'm really grateful that I had the opportunity to work on it.
Yeah. Basically, what this project is all about, we're trying to optimize fuel economy. Basically, helping consumers to make kind of like a demand for more efficient cars, just as we're trying to be a more kind of environmental. How would I say the word? Like more concerned about what our planet is at the moment. Pretty much the idea of the project is that we're looking to find out what vehicle features are most important when it comes to building like a really fuel efficient vehicle, and providing the tools and measures to impact of like those set features basically. So that's what the whole project is about. The data that we have, we got it from an API from a fuelsecom.com API. It pretty much has all the cars manufactured in the U.S. from 1984 to 24. Almost like 47,000 vehicles and 82 features per vehicle, which is like a tremendous amount of data. Some features were like cylinders, displacements, drivetrains, vehicle classes, things like that. Different also like four wheel drive, things like that, compact pickup truck, sports car, automatic, manuals, things like that, was what we used basically. Some of the challenges we faced making these models was that the actual FuelCom API was very it wasn't necessarily outdated because all the information was very up to date. It was just more of the API document wasn't like very clear on how to access the data that we wanted to from that API. The documentation wasn't really put together that great. It was more like, you know, like a government API. So they really didn't put that much effort into making like, you know, detailing the documentations of how to get the information that we wanted. Wasn't very user friendly. The API request and the data collection took a while, about like 12 hours in total of actually running, but then it would run and then it would stop. So it would have like a timeout of like every like 20 minutes or so. So we'd have to consistently keep it going. So if you account for that, it's probably more of like maybe like 18 hours or something like that. So it took a lot of times. There were about like 82 features, like I said earlier. We were trying to decide what features to exclude due to the amount of features we had available. We couldn't really use them all. Even though they say more data is best for this situation, we couldn't use all of it because there was a lot of data, a lot of features. And there was a lot of null values when it came to that data that we had collected. The EDA was very extensive just because of that. Pretty much just all the features that we had to get through and figure out which ones were important, and you know, kind of like narrow down just a couple features that we thought were necessary for this model that we're building.
So I'm going to talk a little bit about the model that we chose, the algorithm that we chose. So to build this model, we chose an XGBoost algorithm for a few reasons. The data set had a lot of features, and a lot of it was categorical values. You know, things like the drivetrain was 4-wheel drive or all-wheel drive. The vehicle class, there was van, there was pickup truck, there was compact car, subcompact, a lot of values. And XGBoost is really good at handling categorical values. If we had to do the handling of the categorical values ourselves by hand, it would have taken a really long time. And XGBoost does a really good job at doing that for you. The other reason that we chose this is because it provides insights on feature importance. And our project is about finding out which features of a vehicle are most relevant towards fuel economy, miles per gallon. So having this insight and understanding where the vehicle itself is mostly using the most fuel to cause miles per gallon to go down. It was what we wanted to know, and having this algorithm that tells us exactly where we can see that pattern is relevant to our project. The speed of the algorithm was good as well. We had a lot of data, and we wanted to make sure that it could run quickly and efficiently, because also the constraints of the technology that we have. We didn't want our models to break our computers, and scalability. So later on, we'll talk about the future of this project and where you can get even more data. So being able to have a scalable project is really important. So after we got our numbers, we made sure that our model was consistent. So our results, as you can see in the next slide, we got it to estimate miles per gallon, to predict miles per gallon for a vehicle that we build between 0.86 miles per gallon and 1.3 miles per gallon. So when we validated our data, we got to a consistent number of 1.28 miles per gallon. We ran the model 5 different times, and that's the average. So we got an idea that our model was being consistent with our data. And when it comes to the results themselves, we used 2 different evaluation metrics. We used root mean square error and mean absolute error. So root mean square error is, it takes into account the difference between predicted values and actual values of the data set. So what we're predicting and what the data is telling us. And then it accounts for the errors in the data in the prediction. And it gives us an average. And then mean absolute error is the same, but without accounting for errors. And that's where we get our results between 0.8 miles per gallon and 1.3 miles per gallon. And as you can see from this plot, we have a error distribution, which is centered around 0 with a normal distribution, which what that means is that the long range in mile per gallon indicates reliability, and there can be some confidence in the people that are using our model to gauge the impact of the different features. This also means that it's equally as likely to overestimate and underestimate the data. So we can be confident that the prediction is between the numbers that we get.
And I'm going to talk a little bit about the features that we used when creating this model. The most relevant features that we saw were displacement, diesel fuel, cylinders, and front-wheel drive. These were the most relative features to a combined like miles per gallon. So pretty much if you compromise any of these, the miles per gallon would pretty much rise substantially or decline if you took them out type thing. So these are the most important ones that we saw. The findings emphasize the impact of engine size, fuel type, and drivetrain configuration on the combination of the miles per gallon of vehicles, providing valuable insights for cars and like manufacturers and stuff. Understanding the significance of these features pretty much aid in the development of more fuel efficient vehicles and potentially guide like the automotive innovations by focusing on like features that are most costly to like miles per gallon. So yeah. You can go to the next model. Here's kind of like a little diagram of like our machine project summary. Hopefully you guys can see it good. We created an XJ boost model using the root mean square error, and then the main, and then the mean absolute error. Oh, excuse me, sorry. And we got a score of like 0.86 to 1.3, which is kind of like the in between of what we were getting when we run these models. It's kind of like the number we were off by compared to the results of the cars when we actually what the manufacturer actually set for them, which means that we can predict fuel efficiency within that range of MPG between 0.86 and 1.3. We tested for overfitting. We had like a slightly overfit, but it wasn't very kind of like I say impactful. Cross-validation of our models, we used a lot to check consistency to make sure we got that same like those same ranges of results. Our most relevant features to contribute to fuel efficiency, or that would be pretty much like cylinders and displacements. But they're all listed there as you can see and whatnot. You go to the next slide.
So now I will run you through the web app. We built a web app using Streamlit that uses this XGBoost model to predict miles per gallon. The way that it works is the user can input their vehicle or whatever vehicle they're trying to build, and I'll show you that in a second. And you input vehicle features, and it gives you a prediction for combined miles per gallon, and that's over here. So as you can see, this is our web app. We have different features that you can input. You can input the cylinders that your vehicle has, how the displacement. So this is when you have a vehicle that is like a 2.5 liter engine. What that means is that it's using 2.5 liters of air when it runs through a whole cycle. So, and it uses the air and the fuel combined to make power. Then the drivetrain, there's two-wheel drive vehicles, four-wheel drive, vehicles that are four-wheel drive or all-wheel drive. Vehicles that you can, like this one, part-time four-wheel drive. It's a car that you can turn the four-wheel drive off whenever you please. Then we have the vehicle class. So we have a bunch of different vehicle classes in the data set. things from compact cars to large cars, two-seaters, a bunch of different pickup trucks, SUVs. Over here, you can see vans. There's cargo vans. There's passenger vans. Just a lot of different vehicle classes that you can choose from. The transmission, you can choose either automatic or manual. We made the compromise in our model because there are so many different types of automatic transmissions that manufacturers use, and they're all classified differently. For user interaction with the model, we made the compromise of combining all those transmissions that are automatic into one group and all the manual ones into another group. Because if someone who isn't exactly super familiar with the different transmission types and what they do and how they work, it would not be as user-friendly in the model. And then fuel type, we have diesel, mid-grade, premium, and regular. We decided to not use hybrid vehicles or plug-in hybrid vehicles and a little more obviously electric vehicles from the data set, because the hybrids and the plug-in hybrids were really big outliers. The data tells you that most vehicles average from 1984 to 2024, between 20 miles per gallon they tend to go around. And a car that is a hybrid or a plug-in hybrid is averaging 50, 60, 70. So that would throw our data way off. And then we have different vehicle features, vehicles that are turbocharged, vehicles that are supercharged. There is a difference. And newer vehicles have this technology that is the auto start stop. When you stop at a red light, the car turns off. You hit the gas, car turns on, goes. This was found to be really important to fuel efficiency. And if you look at studies around the technology itself, the vehicle spending less time on idle has been really relevant to saving fuel in the past couple of years when this was implemented. You can choose which year your vehicle was built. You can choose all the way from 1984 to 2024. And then there's this classification that the government uses for gas guzzling vehicles, and it's vehicles that straight off of that average 20 miles per gallon. This was necessary to be included for the modeling because we had a classification for vehicles that were really, really, really inefficient. But in the future, we would like to remove that from consideration. So what I can show you is I can build a car here. I personally can build the car that I drive right now. I drive a 2022 Toyota Corolla. So it's a 2022 vehicle, which has a 4-cylinder engine with a 1.6 liter displacement. It is front-wheel drive, and it is considered a compact car. The transmission is manual, and it uses regular fuel. And it doesn't have a turbo or a supercharger. And just a fun fact, manual transmissions don't have the auto start stop. There is no vehicle out in the world with a manual transmission that turns itself off. And it was built in 2022, and it is not considered a gas guzzler by fueleconomy.gov. So you can predict, and it says that the combined miles per gallon, so we're predicting combined miles per gallon, which is city miles, highway miles, added together, divided by 2. That's how they get it. When you see a commercial, they go city, highway combined. So we got a prediction of 31.1. In reality, that car is rated for 32.5 miles per gallon. So we're off around 1 point. We're within our range of our model. And you can play around with it. You can make vehicles that don't really exist. You can make vehicles that are 16-cylinder, which there's only a handful. I think if you know anything about cars, a Bugatti is a car that has a 16-cylinder engine. You can make it super gas guzzly, add a supercharger, make it automatic, and you can make it a SUV, sports utility vehicle, and make it diesel. And you can predict. It gives you a prediction. So that would be a horribly, horribly inefficient vehicle. So that's our model. And you can go back here.
And I'm just going to talk about a little bit of like why we did this and also future implementations we want to do down the line for this model. We basically created this because we thought that the manufacturers would be a very useful tool for manufacturers to use to kind of dictate what features they want to put into future models of the cars they created, like maybe Toyota Corollas, like the one that Ricardo has. They're pretty fuel efficient, and maybe they want to make it more fuel efficient and less pricey. They would kind of use our model to see what kind of features of the vehicle they can either leave or add to kind of get that vehicle more fuel efficient and see if it's worth it and see if it affects the price range of the actual car. This model is not only for big manufacturers, it's also for a person that may want to see what kind of vehicle they would want to buy in the future car buying. You can have someone that, okay, I'm a family, I have a family of 4 kids or something, and I need a minivan or an SUV, but I also need something fuel efficient because I have 4 kids. I need something that's going to save me money. So they can use our models to see where they can either sacrifice in features or add in features of their vehicles they want in the future to see what car would be right for them to buy for their situation that they need. And then also for any car enthusiasts that build their own cars and want to, see project cars or things like that, it'd be another tool for them to use to see, okay, how can I build a car that can be super fuel efficient, or can I build a car that's just going to go really fast and only be like 1 mile per gallon, you know what I mean? But yeah, a lot of different people will be able to use our models just to dictate what kind of either car they want to build or buy, or what kind of car that they maybe want to think of, or maybe a concept car that someone wants to create in the future, and they want to see if it's even worth pursuing that concept car and stuff like that. Future implementations we want to put into the project is pretty much incorporate electric vehicles, hybrids, and alternative fuel vehicles into the model. We didn't really focus on that this time just because we were really focused on fossil fuels and miles per gallon instead of actual kilowatts and things like that on other forms. The manufacturer RLD focus, basically, like I said, a manufacturer can either be more fuel efficient on their next models of cars, or you can have luxury cars that are more performance based, and they can use our models to see, okay, where can we sacrifice to make the car faster, but also not totally kill the mile per gallon or things like that, or basically like that. We want to broaden our spectrum in the future of more vehicle types, manufacturer strategies. So we want to put more features in there, what actually goes into manufacturing a car. So we have more features to either take away or put in, so people can dictate what they want. And also worldwide markets. Right now, this is only the U.S. market, and it's pretty much just like a scratch on the surface of all the cars produced in the world. And in the future, we want to put it worldwide, so everybody will be able to use this model and have some data from it.
And with that, we wrap up our presentation. We would definitely like to thank 4Geeks for allowing us to present and giving us the platform and the tools to be able to create this project. And most especially to Sebastian and to Stephen and Pedro for teaching us how to use these tools and guiding us on making this project, and all the lessons that they taught us and the insights that they gave us.
Yeah, I want to second that and thank all the teachers that helped us, Stephen, Sebastian, Andres, I think it was. I can't believe I forgot his name, but yeah, I couldn't have any better. I don't think I can have a better teacher, because these guys are really passionate about what they were talking about, and they actually gave the time and effort to explain to us what the process was for a lot of these models, and their interests and their intuitions inspired me for sure to kind of keep pursuing this course even through the hard times, because I knew that my professors were going to explain and help me get through it, not just explain it and expect me to get it. They actually really worked with me, and it's hard to find someone passionate about what they do, and these guys are very passionate about what they do, and I really appreciate that, and it definitely motivates me. For sure. Thank you, guys.
Any
Yeah,
questions,
any questions?
concerns, thoughts?
Nice job, guys.
Thank you.
Questions, comments?
I would like to commend you guys for choosing a problem that is relevant to the zeitgeist, environmental efficiency, fuel efficiency, environmental concerns, the price of gasoline going up everywhere. So I want to commend you for finding a data set that is relevant to the zeitgeist. And I think you guys are underselling how awful the API documentation is for fueleconomy.gov. It doesn't exist. And also just thanks for creating a really fun app to play with.
Yeah, I feel like I could have probably got more information from the Egyptian drawings on the pyramids than I did from that API documentation. I'll tell you that right now.
Good job, guys. Thanks for your words. I feel like, wow. The first day that I miss something, for example, related to you take a great problem. I think that you can take, or you could take, another problem that maybe are more easy to do, for example, but you guys takes a difficult problem to solve. Congratulations for that. I think that your presentation and your project are really cool.
Thank you very much.
Thank you.
Any other questions or comments for this group? All right, then we will close out. We saw 2 really cool projects tonight. I think that you guys should be really proud of the journey that you guys have embarked on and now finished. Many students start the cohort and don't make it till the end. So the fact that you guys have stuck through, have powered through, and have presented and have graduated is a huge accomplishment. That is why we always like to do the graduations on Friday nights, because we want you guys to celebrate with your families, go out for dinner. I know it's a little late. I'm going out to dinner tonight. Celebrate at home, enjoy your weekend, have, a few days off where you can finally relax. I did it. It's done. And then Monday you start boot camp number 2, which is your Geek Force boot camp. And we help you guys to get your first job. But at least you can have, the weekend to celebrate and to live this huge accomplishment that you guys have done and achieved. Would anybody else like to leave any last minute comments before we close out?
I have a last message to you guys, for all you guys. I wish you continue your path as a DS or email and learn a lot of new problems and face a new challenge on your future. I think that this is mostly the first. You need to continue learning for yourself, and I really enjoy this journey with you guys. Thank you for giving me this time with you.
Thank you, Sebastian. And thank you for being a TA for this group. It was really awesome for us to have you.
Sebastian has been a capital T, capital A. Put it in gold, put it on platinum and silver encrusted with diamonds. Sebastian has been amazing. I would just like to quick shout out to the group that is still here. I'm going to put a link in the Slack channel to go back to our original. I just want to debrief with you guys after this. But you guys have done an amazing job. I love the progress that you've made. Thank you, Roger, for joining us and sitting in and giving us some helpful hints as the group moves forward to the next phase of their journey, because this has been a hero's journey for them. Absolutely.
Yeah, I just wanted to say again, thank you for the teachers. You guys are great, and I hope you guys keep helping others, because we lucked out with our teachers. I know different other people in different classes don't have the best professors, and then we lucked out with our professors for sure. So I just hope you guys stay with it and keep helping others for sure. You guys definitely helped us. something that would definitely try to change our lives for sure.
Yeah, thank you, Stefan, a lot for coming into this cohort. I've heard only good things about you and very, very good ratings about you. So thank you so much.
They did the work.
Thank you for your time, Stephen, for sharing your knowledge and your experience. You are a great teacher and a great person.
You have really cool whiteboards too. Thanks for all the whiteboards.
Yeah, you remember me that it's work with a board again.
You guys are going to make me blush in front of Alyssa and Roger. Stop it. No, thank you all. This has been a great group. They've been willing to put all the work in, all the effort in. They've asked great questions. They've done all, and they've come up with great ideas along the way. Things that I personally never would have thought of in my wildest imaginations. They just came with great ideas. Smart people doing smart things. That's what the group that I walked into, and it's all due to their own hard work. I will just repeat that ad infinitum.
That's awesome to hear. Congratulations, guys. Anybody else? Or shall we part for our celebrations?
It's time to celebrate.
It's time to celebrate. All right, guys. One more big congrats. You know that you have all the support that you need. Message me, message Laura. We're here for you. Enjoy your weekend. We're going to see you guys next week. Ciao.
Thank you very much, guys.
Thank you all.
Bye,
Take care.
guys.
Thank you.
Chao, chao. Que pasen bien, chicos. Bye, bye.
Cuídate.